Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest, minimum increment operations to make array beautiful. The problem states that you are given a zero indexed integer array nums having length n and a integer k. You can perform the following operation any number of times. Basically, you can take any index I and increments its value by 1. Now, array is called beautiful if for every subarray of size 3 or more, maximum element is greater than equals to k. You have to return the minimum number of increment operations that you need to make the given array nums beautiful. So let's take an example. Let's say nums is 23002 and k is 4. So we need to return the minimum number of increment operations that we need to perform such that the given array becomes beautiful. And basically every subarray of size greater than equals to 3, the maximum element should be greater than equals to 4, yes. So what they have done is they incremented the first value here, or the first index here. The first index now becomes 4. After that they incremented the last index by 2 times, so it will become 3 first and then 4. So in total we have done 3 increment operation. Now think about this array. In this array, for every subarray of size greater than equals to 3, the maximum element is always greater than equals to 4. So this is one subarray of size 3, maximum element is 4. This is one subarray of size greater than 3, maximum element is 4, maximum element is 4. Similarly, this subarray, maximum element 4, maximum element 4, and finally this subarray, maximum element is 4. So for every subarray of size greater than equals to 3, maximum element is 4, and you can try out any other possible combination. You will not be able to achieve this configuration in less than 3 operations, and hence the answer here is 3, right? So hope the problem statement is clear. Now how to solve this? As always, if you in the problem you are given that focus on every subarray of size greater than equals to 3, then try to reduce that part first. As always, like we have seen this multiple times in this channel, in this kind of situation, more often than not we will be able to reduce this to a smaller constraint. So currently we have to take care of every subarray of size 3, 4, 5, 6 all the way up to n. But think about it, if you take care of a subarray of size 3, in other words, if every subarray of size 3 has maximum element greater than equals to 4, it implicitly means that every subarray of size greater than 3 will have maximum element greater than equal to 4 as well. So basically the definition is that this subarray, every subarray of size 3 is greater than equals to k. Let's say for now assume k is not 9, k is something less, so let's say k is 5 for now, right? So every subarray of size 3 has maximum greater than equals to k. Now if you increase the size of the subarray, you are including more elements. Whatever element you already had, that element you currently have in your subarray as well, you are including more elements. And we already have said that every subarray of size 3 has maximum element greater than equals to k. So it implicitly means that every subarray of size greater than 3 will always have the maximum value greater than equals to k as well. So this condition, we can simplify this and say we need to make sure that every subarray of size 3 is greater than equals to k. That's all. Everything else will be taken care of. So that's the very first observation here. Now let's say k is 9 and this is the given array. We need to make it beautiful, right? So let's start with the first index, or rather the first subarray of size 3. So we need to make this subarray beautiful. Basically the maximum element should be greater than equals to 9. Now how you can make this subarray beautiful? you can either change this element, you can either change this element, or you can change this element. You have three choices. Let's say you change this element, you change this element to 9. Obviously you will not change it to greater than 9 because you want minimum number of operations. So as and when you are increasing the value, you are increasing the operations as well, so you will try to keep it as minimum as possible. So you kept it 9. Now once you do it 9, you know that this subarray is taken care of. Now you want the minimum number of operations to make the remaining array good or beautiful. Isn't this problem exactly similar to the original problem? Original problem was, given an array, find me the minimum number of operations in which I can make the subarray beautiful. The reduced problem was, I changed one of these, let's say I changed this, now give me the minimum number of operations in which I can make this remaining array beautiful. Similarly, if you haven't changed this, instead you have changed this to 9, again the problem would not have changed. Problem will say, okay, find me the minimum number of operations in which the remaining array is beautiful. And in the same fashion, if you have it changed this as well in the first operation instead of these two, then again the problem would remain same. The find me the minimum operation to make the entire, to make the this part of the array beautiful, right? So hope you can see the recursion here. So let's see this in action. We have this this array with us, k is 9, right? So as we said, we will only care about the first subarray of size 3. So for the first subarray of size 3, to make it beautiful, we have three choices. Either it is beautiful by 0th index, or it is beautiful by first index, or it is beautiful by second index. In other words, either 0th is greater than equals to 9, or 1th is greater than equals to 9, or second element is greater than equals to 9. So if you make the first element greater than equals to 9, then this is your state. So the remaining array would be 6, 8, 9, 7 and so on, and you have to add 4 operations to it as well, because you are saying that you are changing the first element, right? Similarly, if you pick the second element, right, so this will be your state. Basically now you have changed this 6 to 9 and you are saying what is the minimum number of operation to make this array beautiful, and for this you have done 3 operations here, right? In the same fashion, if you have changed this element, then you have done 1 operation, and now you are saying, now this is changed to 9 and you are saying give me the minimum number of operation to make this part of the array where this 8 is now no longer 8, it has become 9, to make the given now you want this array to be beautiful, you want minimum operations to make this possible. So each of these are a sub problem, so you can exactly apply the same trick. In other words, what you can say, let's forget about these things, you can treat this as an independent array and say, okay, I will now only worry about the first subarray of size 3. Now I can change the first index or the second index or the third index and make it beautiful. So let's say I change the first index, so in that case I have added 3 operations, and now I need what is the minimum operation to make the remaining subarray 8, 9, 7, 8, 6, 7, 4, 2 as beautiful. Similarly, if you have chosen the second index instead of first one, then you would have added 1 operation to make this 8 to 9, right? And after that you will say what is the minimum operation to convert everything else into a beautiful array. And in the same fashion, if you have chosen the third index, so third index is already good, so you will not change anything there, so you have done 0 operation, and now you are saying what is the minimum number of operations to make this array beautiful. So in the same fashion you will continue further, and at the end when you will reach the subarray of size 2, you will just return 0. Basically you will not be able to make, so if you keep on doing this operations, at the end you will reach something like, let's say 4, 2. So once you reach this state, you will say, okay, I can't have more than I can't have any subarray of size 3, so I will just simply return 0 here. So this is our base case. any subarray of size less than equals to 2 is our base case. In that case, I will return 0. So hope this entire solution makes sense. Simply we are taking care of the first subarray and relying on the recursion to solve for the rest. So how would the pseudocode look like? Pseudocode would simply look like this. Notice that instead of passing the entire array, we can have only two index changed. So if we are taking care of the subarray starting at 0, only index that can change is 1 or 2. 0 will also change, but it doesn't matter if 0 has changed or not for the rest of the array. So only two index are changing with respect to the rest of the array. So instead of passing the entire array in the next state, we can simply keep track of the next two elements, and that should be sufficient. So that's what we have done. Instead of passing the entire array, we simply keep track of what is the next what is the value of the current element and what is the value of the next element, because that's the only two things that will change. Other things will not change. So if you can see here, in this state, either this would have changed, like the original array was 5 6 8, so either this 6 would change or this 8 would change in the next state, right? Nothing else will change. So that's why we only keep track of current value and the next value, nothing else. Now inside this, we simply have done the three operations that we discussed. So either we can change the first index, the second index, or the third index. So if the first index, notice that the first index value is not array of index, instead this current val, because this might have changed in the previous iteration. So we will not rely on array of index, instead we will rely on this current val. So if current val is greater than equals to k, then we will not change anything and simply return 0, right? Basically we don't need any extra operations. If current val is not greater than equals to k, it means we need some operation, and how many minimum operations we require is k minus current val. This many increment operation we will require to make current val equals to k. Now after this operation, or basically after changing the first element to k, we will simply check what is the minimum number of operation required to make the remaining to make the remaining array good or beautiful, right? So we haven't changed anything here for index. So in this case we just have changed this index, right? But for the next indexes we haven't changed anything, so this will remain as it is. So whatever the value of next index was, that will now translate to the current value, and the array of index plus 2 will be the value of the next index. Now the next criteria is we can change the first index instead. So if you change the first index, basically the next val, if next val is greater than equals to k, you don't need any operation, otherwise you need this many operation, k minus next val. Now once you have figured out how many operations are required to make the next val equals to k, in other words what we are saying is we are changing index 1 to k. Now once we figure out this operation, we can simply move to this state. Basically we will say the first index is now changed. Previously whatever it was there, now it is k, and the second index would remain as it is, and now figure me what is the minimum number of operations required to make the given array beautiful. So that's what we have done. The first index is k and the next index remain as it is. So now give me the minimum operation required to make the given array, to make this remaining array beautiful. And finally if we change the last index, so the last index will not have changed, so that's why we just rely on array of index plus 2, right? So if the last index is greater than equals to k, we don't need any extra operation, otherwise we need some operation which is k minus array of index plus 2. Once we make it equals to k, we can then we have to make the rest of the array beautiful. So let's say if you change this element and make it equal to k, so what you have done actually is you want rest of the array which is starting from 6. So this element stays as it is, this element has now changed to k or 9, and rest of the things stays as it is. So that's what we have done. The next element would stay as it is next of val, and the element after that will be changed to k. So now we will find out what is the minimum operation required to make this a beautiful array, right? So after we have done this, we will take the minimum across all of them, and that will be our final result. Now one more thing to note here is we may encounter the same state again and again, right? So you can see these states are exactly same. So basically they are saying find me the minimum number of operations required to make this array beautiful. This is also saying find me the minimum number of operations required to make this beautiful, and this is also saying that. So we will have duplicate sub problems as well. So that's why we have simply done memoization here. We simply keep track of whatever we have discovered already, and if we encounter anything which we have already discovered, we will simply return that value instead of recomputing it. So this will make sure that we don't recompute the same state again and again, and the final time complexity of this entire solution would simply be number of states multiplied by what's happening inside each state. So what is happening inside each state? We are doing some min operations and doing some computations, some mathematical computations. So all of these is just order one time. So basically we are doing constant number of operations inside this inside each of these state. Now how many states we have? That will be equals to the number of different values of this distinct value in which this f can be called. So number of distinct value of index would be n, number of distinct value of current val could be all the way up to k, and similarly next val could be all the way up to k. So the complexity is n k square, which will not pass because k is very huge, right? So we have to optimize this. Now if you have been watching this channel from some time now, I am very confident that you should be able to optimize this by yourself. Just try to pause and think about which of these state are unnecessary, or if it is necessary, can we replace it with something less than which is not equals to this current val or not the actual value itself. So hope you thought about it. Notice that what we are changing to. So every time we are changing the value. So let's say you changed something to, you change something here, you change this 5. So where to what value you will be changing this 5 to? You will be changing this 5 to k, nothing else, right? Not more, not less. Similarly, if you are changing this 6, which value you will change it to? Again k, not less, not more. So we just need to make sure to track what is changing. What is the value after the change? We already know. We already know the value after the change would be 9. We just need to track what exactly is changing, the element next or the element after that, right? So we can simply replace this current val and next val with is current changed, is next changed, and if the boolean is true, we know what will be the value. So instead of k, this 2k will be replaced with boolean values which will take at most 2 state, true or false. So this nk square would now become 4n, which will pass the given time constraint, right? So the pseudocode would be exactly similar. Only thing that changed here is the current changed and the next changed. So what we are saying is, if current is changed, the value is already k. So we will not. So notice that where we are using this current value. We are using this current value to figure out what is the number of operations required to make it equals to k. So that's to that what we are saying is, if current is changed, we know there is no operation required. So if current is changed, we will not take any operation. If current is not changed and the array is value itself is greater than or equals to k, then also no operation is required. Otherwise this many operation is required, right? So that's the basic trick. We are not doing anything fancy here. we are just checking whether it is changed. If it is changed, we know what it will change to. It will change to k. That's the only thing. Rest of the thing is exactly as similar. So if you have watched till this point, I would strongly encourage you to pause and try to code this entire thing by yourself, because that's the point where you will understand which piece is not clear, so that you can revisit and watch that particular section. So next we're looking at the code. The code is exactly similar to what we just discussed. We have this memoization array to just keep the state with us, and after that we are simply calling this function with 0, false and false. This false denote that the current element is not changed and the next element is also not changed. Now inside this, what we are doing is we just figure out whether the first one is okay or not, second one is okay or not, third one is okay or not. Basically whether they are greater than equals to k or not already. So either they are greater than equals to k or they are changed. If they are changed, I'm sure that it will be equals to k, which is already greater than equals to k. So this is whether 0th index is okay, whether first index is okay, and whether second index is okay. Now if 0th, now this is the three states. We have to change we can either change the first index, we can either change the second index, we can either change the third index. So for changing the first index, we will just see what is the total number of operations required, right, to change this index to something greater than equals to k, or basically equals to k itself. And for the first operation we'll do the same. We'll see how many operations are required, and because we have changed the first index, we will simply keep this one true and the next one as false. Basically we haven't changed the next index, but we have changed the current index. Current index basically will be index plus 1 itself. In the same fashion, for the second index as well, we'll see if we have changed that already. If we have, basically if okay is not true, we'll figure out how many operations are required, and based on that we will figure out what is the number of operations required to make the rest of the array beautiful, right? So we'll just take minimum across all of them, and that will be our final result. So hope this entire solution makes sense. If you have any doubts, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already, and I will see you in the next one. Thank you.